Good morning, everybody. Yesterday we were talking about volumes of cylinders and, what do you know the other word? Prisms. Okay, so we have an example of a prism here, and also our triangular prism and our cylinder. Today we're going to do the same thing, but we're going to look at two different shapes. We're going to look at pyramids and cones. Thank you, Ivan. Okay, so volume of a pyramid and volume of a cone. So how much can we fit in each one? Like this one, we have an example of our squares. We can figure out the space that we have inside the cone. Okay, so we have a couple notes on the board that you guys already took down. We took down the volume of a pyramid and the volume of a cone. What do you notice about the difference between the volume of a pyramid and cone compared to the prism and the cylinder?
They have 1/3.
It's 1/3, right? So it's actually cut into 1/3. So yesterday the volume of our prism was volume equals base, area of our bases times the height. This one, our pyramid, we have to cut it into 1/3. Same thing with our cone. Yesterday we had a cylinder. It was a whole cylinder. It was volume just equal pi r squared times the height, yes? Mm-hmm. Okay, today it's 1/3 of it. So we're going to go ahead and do some examples on the board. Just make sure you write these down on your paper. We've got 4 quick examples we're going to go through. Can you turn the light on, please? Thank you. Okay, so the first one, we're going to look at our pyramids first. So once again, somebody yell out the formula for a pyramid for me.
V equals 1/3 base.
1/3 base times height. So remember that big B is actually the area of our base. So what kind of base do we have for both of these pyramids? Look at this. They're rectangles, right, or squares. So we're going to go ahead and we're going to use our base of a square. So what's the area of a square equal to?
Base times height.
Base times height, or
S squared.
S squared. Okay, so let's start off with our first example. Can someone go ahead and tell me what the height of the pyramid is? Do we have the height?
No.
No. How can we figure out the height of this pyramid?
Pythagorean theorem.
Pythagorean theorem. Okay, so first of all, let's figure out what our hypotenuse is. What's the length of our hypotenuse?
25.
25. So we'll go ahead and start with our c squared, which equals a squared plus b squared. So we have 25 squared, which equals 40 squared plus
X squared.
He's not in this class. Okay. 40 squared plus h squared. Okay, so 25 squared.
Oh.
625. 40 squared.
1,600.
1,600. Are you sure?
Mm-hmm.
Yes.
Okay, so what did I do wrong?
It's 40.
It's half, right? So I did the full length of the base, which is a square, but what piece did I take out?
The whole line.
But what piece did I take out?
Like,
But what is this red piece right here? What is it?
oh,
A triangle?
It's a triangle. Okay, so I can't take this full length. I have to bisect it
So it's 20.
and take out the piece. Yes, so it should be 20. Okay. You guys got to make sure you bisect your pyramids. That way we get the correct answer.
What is it, 400?
So we have 20 squared, which is
400.
400. Okay,
Subtract.
so I'm going to combine my terms and subtract 400 from both sides.
225 equals h squared.
225.
Yes.
So h is equal to?
15.
H is equal to 15. Okay, so now I can figure out B, which we'll just do Now this isn't drawn to scale. These are actually should be even, so this should be 40 as well. My drawing's a little off, but I'll go ahead and give you that length. So the area of my base is 40 times 40, right? Which gives me
1600.
the 1600. Okay, so now that I have my big B, my little h, I can plug it back into my original formula. Okay, so I had volume equals 1/3, 1600 times 15. Pick a number when everybody gets it. Yes,
So you do 15 times 1600 and divide it by 3.
yes.
8,000.
8,000. So the volume of our pyramid that we have here is equal to 8,000. Okay. So I'm going to copy that down, and then we'll go ahead and try another one. But first, anybody else, give me the volume of a cone real quick, so we can write that down.
1/3 times pi r squared times h.
Do we have that? Yeah, see a couple people writing, I'll give you a couple more minutes. Okay, so let's go ahead and move on to this next one. Okay, so I'm also missing what here?
Height.
The height. So I have my slant height, which we determined is the hypotenuse. Okay, so then the only thing I have left to do is find out this bottom leg, which we can determine by the side of the pyramid, which is, thank you, 8. Okay, so let's go ahead and start with finding our height. So we know height, our hypotenuse is 17. Okay, so we have 17 squared, which equals
8 squared.
8 squared plus h squared, right? 17 squared? Anybody? 189? 289. And 8 squared, we all know, is 64 plus h squared. Simplify that for me. H squared is equal to 225. So h is equal to 16. So there we have h. So now we just need to solve for the big B, right? So we have a square once again, and we know that because our sides are congruent. Okay, so b equals s squared, or we're squaring what number?
16.
16. So we have 16 squared, which equals
256.
256. Okay, so now I can go back and plug it into my original equation. I have volume equals 1/3 of our area of our base, which is 256, times our height, which is 15.
1,280.
1,280?
Yeah.
Do you have a consensus on that?
Yes.
Yes? Okay. So volume is a little bit easier than surface area because we don't have to worry about slant height. We're looking at the height of the actual pyramid. But you have to remember, if you're not given that height, we can always use what theorem? Pythagorean theorem. Okay? I don't see any more writing. So let's go on to a cone. So you guys told me the formula for a cone is 1/3 pi r squared times the height. So r is equal to what, everybody? Radius. Right? So R is our radius. And H is our height. Okay. So for number 1, what's our radius? 15. Why is it 15 and not 30?
Half.
Radius is half of the diameter, right? So our R is equal to 15 and our height is equal to
25.
25.
Do we use pi or we just leave it?
You can leave it in terms of pi. I'm fine with that. But make sure if you're doing a test or a worksheet, it tells you leave in terms of pi or round to the nearest tenth. Make sure you're doing what is asked of you so that way you get the correct answer. So 15 squared times the height, which is 25. So 1/3 we're leaving pi alone. 15 squared is
225.
225. So if we're leaving in terms of pi, I don't have to touch that pi. I'm just multiplying 225 times 25 divided by 3, and I can leave pi in there. And then when someone has an answer. 1,875 pi?
Yeah.
Do you have a consensus?
Yeah.
Yes.
What happens if I were, say, given the slant height? Could I figure out the height if I didn't know what this number was?
Yeah.
Yes, still using what formula?
Pythagorean theorem.
Pythagorean theorem. Okay, so sometimes you might not be given the actual height of the cone, you might be given the slant height. But once again, just like our pyramid, we can use Pythagorean theorem to find that missing length. And I'd still have to bisect my diameter as well. Okay, this is what we call an oblique cone. It's not a straight-on cone, so we have to look at the height outside of the cone. Okay, and usually you can tell the height because it's attached with a 90-degree angle. But you have to make sure that we're using this height outside and not a height that's given inside. Okay, so we'll use the same formula. Volume equals 1/3 pi r squared h. R is equal to what, everybody? 2. And our height is 6. So once again, we can leave in terms of pi. We get 2 squared times 6. And volume equals, when somebody gets over 8 pi?
Yeah.
8 pi inches squared. Okay, so make sure you have these examples down. We're going to do a quick worksheet. There's a couple questions on it. I want you guys to practice using these formulas. Practice makes perfect. Okay, take one, pass it back. And remember, make sure you read the directions. So the first one, it says you need to, the first 2 problems,
Yeah, you're gonna have to get up.
round to the nearest tenth, right? But number 3 and 4, right underneath it says leave your answers in terms of
Pi.
pi. You can work with the person directly next to you. But if you need help, please make sure you're asking me for clarification. That way you can understand exactly what's being asked. Okay. These worksheets ask you also to list the equations. So we're using the 2 different equations in what shapes?
Pyramid and cones.
Pyramids and cones. Okay.
R squared times H.
Pyramid though. So pyramid, we're not using pi and radius. We're using
Base times height.
base times height. So go ahead and write your equation in.
Can I put the work on the back?
Yes, you can put the work on the back. Okay, so what kind of base do we have here?
The square? No.
Is it a square? Look at
No.
the different lengths.
Or rectangle.
A rectangle, right?
Yes.
So to find the big B, it's the area of a what shape? You just told me.
A rectangle.
A rectangle. Okay. So what's the area of a rectangle?
Isn't half of it?
Not
So,
half. So we're using base and
The height.
height. So area of a rectangle, or let's say B equals area of rectangle. Okay. Ooh. So then B equals, we'll call it a small b times the h. So this is just the area of our base. This doesn't include the actual pyramid. Okay.
Okay.
So then we have big B equals what two numbers?
25 and 12.5.
Right. So then use your calculator, plug that in. And what's the height of the pyramid?
23.
23. So then you have all your unknown variables, yes?
Yes.
Okay, so go ahead and multiply those out. That's 3. Yeah, make sure you plug it in.
You divide it by 3 or?
Well, hit equals first and then divide by 3.
576.
2,395.8.
Yes, exactly. How you doing, David? Cut one more time.
Sorry, 18.
Okay, so how are we going to find the height here? Right, Pythagorean theorem, because we're given the
A and the B.
right. But this is. Do you remember what this is called?
Or the height.
What kind of height though?
Slant
The slant height, right? Because it's slanted. Okay. How you doing, Paris? So the first one, just a quick question. Do you have to use anything to find the height? Do you have to use any other formulas, or are we already given them? Well, do we have to?
No.
No, right? Because we're already given the height, and we know that this is the height because it's attached to what? Right. The slant height would be off to the side like this, going all the way to the edge. Okay, and that's when we would use Pythagorean theorem. How you doing, Franco? Okay, so what kind of base is that, first of all? Is it a square or rectangle, or? It's a rectangle, right? And we know that because these are two different lengths. So this would be big B, which is giving us the area of rectangle, right? So how do we find the area of a rectangle?
You have a rectangle, you multiply this, right, by that.
Right, so big B should equal little b times little h, which we'll call these two, for just the rectangle, okay? So then, B equals 25. Okay, so go ahead and write that down. And then what's the height of our pyramid?
23.
23. So then now you have big B and you have your H. then you can
So you
plug
just
those in.
multiply those right here, and that's
And divide by,
1/3.
yeah, divide by 3.
Oh, alright.
But the big view and the big view.
So what kind of shape is it? This down here, the base. The right click is to have it find the area where
Plug it in like that, plug it in, and then
so then we put base on tight, and that'll give you.
what's 1/3? I didn't do it.
Yeah.
Little 20.
How you doing?
I think I'm doing good.
Yeah, good job.
Oh no, the 23 is alright. No idea.
Because the base is this right now, right? And that's what big B is. We're trying to find the area of this big base. So what kind of base is this?
Square.
It's not a square because the sides are
Triangle.